Gravity never takes a break. It pulls mountains down. It pulls oceans toward the earth. It pulls you into your chair right now. So here's a question that sounds simple, but breaks everything you think you know. If gravity pulls everything down, why doesn't the moon crash into Earth? Right now, at this very second, Earth is pulling on the moon with enormous force, not gently, not weakly. The pull between Earth and the moon is so strong it lifts entire oceans and creates tides across the planet. Billions of tons of water rise and fall because of that pull. So why doesn't the moon fall too? Why does it just hang there in the sky, calm and steady, night after night, as if gravity forgot about it? Many people think the answer is easy. They say there is no gravity in space. That is completely wrong. Gravity in space is everywhere. In fact, the moon feels almost the same gravitational pull from Earth as you would if you were standing thousands of kilometers above the ground. Others say the moon is just too far away. That sounds reasonable, but distance does not turn gravity off. Gravity stretches forever. Even at the distance of the moon, Earth's pull is powerful and constant. So what is really happening? Here is the twist that destroys intuition. The moon is falling. It is not escaping gravity. It is not ignoring gravity. It is falling toward Earth every single second, and yet it never hits. That sounds impossible. How can something fall forever and never crash? That is exactly what you are going to understand today. And once it clicks, gravity will never feel the same again, because falling does not always mean moving straight down. Falling can mean moving forward so fast that the ground keeps curving away beneath you. This is the hidden rule that keeps the moon in the sky. This is the same rule that keeps satellites above your head, the same rule that keeps astronauts floating in space, the same rule that controls every planet orbiting the sun. In this video, you will learn why the moon is actually in constant free fall. You will learn how speed, not distance, is the real secret behind orbit. You will learn why if the moon slowed down even slightly, it would spiral inward, and why if it moved just a bit faster, it could escape Earth forever. You will also discover a lesser-known fact that most textbooks barely explain. The moon is slowly moving away from Earth every year, drifting about 3.8 centimeters farther annually because of tidal interactions. That tiny shift is proof that this balance between gravity and motion is not frozen in time. It is dynamic, it evolves. Long ago, scientists struggled to explain this mystery. When Isaac Newton first described gravity, he imagined a cannon on top of a very high mountain. Fire the cannonball slowly, and it falls to the ground. Fire it faster, and it lands farther away. Fire it fast enough, and the earth curves away beneath it. The cannonball keeps falling, but never lands. That thought experiment changed human history. It revealed that orbit is not magic. It is motion plus gravity working together. And here is another fact that sounds unreal but is true. Astronauts on the International Space Station are not beyond gravity. Earth's gravity up there is still about 90% as strong as it is on the surface. They float, not because there is no gravity, but because they are falling around Earth at incredible speed. The moon is doing the same thing. It is moving sideways at about 1 kilometer per second. At the same time, Earth is pulling it inward. The result is a perfect curve, a constant fall that never ends. When you look up at the night sky, you are not seeing a frozen object. You are watching motion. You are watching balance. You are watching a cosmic fall that has lasted over 4 billion years. And the stability of life on Earth depends on it. Without the moon's orbit, Earth's tilt could wobble wildly. Seasons would become extreme. Climate patterns could shift in violent ways. The calm rhythm of tides that shaped coastal ecosystems might disappear. So this is not just a sky mystery. It is part of the reason we are here at all. By the end of this video, you will clearly understand why the moon does not crash into us, what orbit really means, and why the idea of falling is far more powerful and surprising than it sounds. You will see gravity not as a simple downward pull, but as the architect of motion across the universe. And the next time you see the moon glowing above you, it will not look quiet anymore. It will look dynamic, alive, in motion, falling endlessly around our world. Stay with me, because the deeper explanation will challenge the way your brain pictures space itself. It will replace the simple up and down view with something far more accurate and far more beautiful. Welcome to our channel, where we break down the biggest mysteries of the universe into clear and simple ideas. If you enjoy exploring space, physics, and the hidden rules that shape reality, make sure you subscribe and join us for the journey ahead. Most people answer the moon question with confidence, and most of them are wrong. The first answer sounds logical. There is no gravity in space. That is false. Gravity does not stop at the edge of the atmosphere. It does not fade away once you pass the clouds. Gravity stretches across space. It reaches the moon easily. In fact, Earth's gravity is the reason the moon stays close to us at all. Without it, the moon would drift away into darkness. Another common answer is that the moon is simply too far away for gravity to matter. That also sounds reasonable, but it is wrong. Distance weakens gravity, yes, but it does not erase it. Even at nearly 384,000 kilometers away, Earth pulls on the moon with immense force. That pull is strong enough to lift entire oceans. Every day, tides rise and fall because the moon and Earth pull on each other. Water moves across the planet because of this invisible connection. That is not weak, that is powerful. Then comes another idea. Space has no pull. Space is empty, so nothing is acting on the moon. Completely wrong. Space may look empty, but gravity fills it. Every object with mass pulls on every other object. Earth pulls the moon pulls Earth, the sun pulls both of them, Jupiter pulls too. Everything is connected by gravity. It is quiet, it is invisible, but it never turns off. And here is the part that builds tension. Earth is pulling the moon right now, not gently, not slightly, very hard. The force between them is enormous. If you could feel it directly, it would shock you. So now the real question becomes sharper. If Earth is pulling the moon so strongly, why does it not crash? Why does it not spiral down and slam into the planet? Here is the twist that changes everything. The moon is falling. Yes, falling. That is not a metaphor. It is not poetic language. It is literal. The moon is constantly falling toward Earth. Every second, gravity pulls it inward. Every second, the moon responds to that pull, yet it never hits, it keeps missing. That sounds impossible at first. Falling usually ends with impact. Drop a rock, and it hits the ground. Drop a cup, and it shatters. Falling seems simple. You move downward until you collide with something solid. But that idea is incomplete. Falling does not mean moving straight down. Falling means moving towards something, because gravity pulls you. Direction does not matter. What matters is attraction. The moon is falling toward Earth, but it is also doing something else at the same time. It is moving sideways, very fast, about 1 kilometer per second. That is roughly 3,600 kilometers per hour, faster than a bullet from many guns, faster than a jet aircraft. The moon is racing sideways through space, while gravity pulls it inward. Now picture a simple example. You pick up a rock and throw it. It moves forward, but gravity pulls it down, so it follows a curved path and lands on the ground. Throw it harder, and it travels farther before hitting the ground. The curve becomes longer. Throw it even harder, and it goes even farther. There is always that downward pull, but the forward speed keeps it moving ahead before it lands. Now push that idea further. Throw it so fast that as it falls, the ground curves away beneath it. Earth is round. Its surface curves. If the rock moves forward fast enough, the curve of its fall matches the curve of the Earth. It keeps falling, but the ground keeps dropping away at the same rate. The rock never lands. It keeps missing. That is orbit. The moon is that rock. Earth is that curved ground. Sideways speed plus inward pull creates a continuous curve. The moon falls toward Earth, but its forward motion carries it around Earth. It keeps falling. It keeps missing. Over and over again. This balance is precise. If the sideways motion were weaker, gravity would win more strongly, and the moon would spiral inward. If the sideways motion were stronger, the curve would widen, and the moon could drift away. Right now, there is a balance, a constant negotiation between motion and pull. This destroys the simple idea of falling as straight down. Falling is not about down. Down is just toward the center of a massive object. On Earth's surface, down feels vertical because we stand on the surface. In space, there is no up or down in the usual sense. There is only attraction. If you are moving towards something because of gravity, you are falling. By that definition, satellites are falling. Every communication satellite that sends signals to your phone is falling around Earth. The International Space Station is falling. The astronauts inside are falling too. They float, not because gravity disappeared, but because they are falling at the same rate as their spacecraft. Everything inside falls together, so it feels weightless. The moon is doing the same thing on a larger scale. It is trapped in a permanent fall around Earth. Now think about what would happen if one part of this balance changed. If the moon suddenly stopped moving sideways, even for a moment, gravity would pull it straight inward. It would begin to move closer, faster and faster. It would not just gently drift down, it would accelerate. The closer it came, the stronger the pull would become. Eventually, it would crash into Earth with unimaginable energy. The impact would reshape the planet. Oceans would rise in massive waves. The surface would melt in places. Life as we know it would not survive. All because sideways motion stopped. Now flip the situation. Remove Earth's gravity completely. If gravity vanished, the moon would not stay in place. It would not hover. It would continue moving in a straight line at the same speed it already has. That straight line would carry it away into deep space. It would leave Earth behind forever. No tides, no bright disk in the night sky. Just emptiness where it used to be. Gravity keeps it bound. Speed keeps it from crashing. Or imagine increasing the moon's sideways speed, just a bit faster. The curve of its path would widen. The orbit would stretch. If the speed reached a certain point, the moon would achieve escape velocity. It would break free from Earth entirely and become its own wandering object, orbiting the sun. A small change in speed would mean a completely different future. This delicate dance between speed and gravity is not unique to the moon. Planets orbit the sun the same way. Earth itself is falling toward the sun right now. Every second, the sun's gravity pulls Earth inward, but Earth moves sideways at about 30 kilometers per second. That enormous speed keeps it missing the sun. We do not fall into the sun because we are moving fast enough sideways. The entire solar system works like this. Mars falls around the sun. Jupiter falls around the sun. Saturn falls around the sun. Each world is in a constant state of controlled falling, and the pattern continues on larger scales. The sun itself orbits the center of the Milky Way galaxy. It falls toward the massive concentration of stars and matter at the galaxy's core, but it also moves sideways, so it keeps missing that center, circling it over hundreds of millions of years. Galaxies interact the same way. They pull on each other, curve around each other, sometimes merging, sometimes missing in slow, graceful arcs that last billions of years. The universe is full of motion shaped by gravity, objects chasing each other, objects missing each other, objects locked in endless curves. The moon does not resist gravity. It obeys it perfectly. It responds every second to Earth's pull, but it also obeys motion, motion that began billions of years ago when the moon first formed, likely after a massive collision between early Earth and a Mars-sized body. That violent beginning set the moon moving. Gravity shaped the path, speed preserved it, and since then the fall has never stopped. Each second that passes, the moon drops slightly toward Earth. Each second, it moves forward enough to miss. The path curves smoothly, a circle, more precisely an ellipse, repeating over and over. About once every 27 days, the moon completes one full orbit relative to the stars. a continuous fall that loops back on itself. There is no invisible string holding it up, no hidden force pushing it away, only gravity and motion, only falling and missing. When you look at the moon rising above the horizon, it feels calm and steady, but what you are really seeing is motion at incredible speed. You are seeing gravity at work, across vast distance. You are seeing a balance so stable that it has lasted for billions of years, yet so delicate that a change in speed or mass could transform it completely. The idea that falling can create orbit changes the way you see the sky. It turns stillness into movement. It turns stability into dynamic balance. It reveals that what looks peaceful is actually powerful. The moon is not hanging in place. It is racing sideways. It is dropping inward. It is curving through space in a path shaped by invisible force. And this pattern repeats everywhere, from small satellites to giant planets, from planets to stars, from stars to galaxies. The universe is not a collection of objects sitting still. It is a system of endless falls, endless curves, endless near misses that never quite become collisions. Motion plus gravity, speed plus pull, that is the rule. That is why the moon does not crash, and that same rule keeps shaping everything far beyond our night sky, where countless worlds are falling around distant stars, tracing silent paths through the dark, always pulled inward, always moving forward, forever missing, forever falling. The moon doesn't avoid gravity, it obeys it, perfectly. Every second of every day, gravity pulls it inward with tremendous force, and every second the moon responds without resistance, without pause, following the exact path that force demands. It is not escaping, it is not defying the laws of nature, it is following them with absolute precision. What once looked like defiance is actually obedience. What once felt like a mystery is actually balance. The real mystery was never why the moon doesn't fall. The real mystery is how falling creates motion, how a constant pull inward can produce a graceful curve instead of a collision, how speed transforms a crash into a circle, how the same force that drops a stone to the ground can also hold an entire world in the sky for billions of years. That is the shift in understanding. Falling is not the end of motion. Falling is motion, controlled, balanced, endless. The moon is not frozen above us. It is not hanging in space. It is racing sideways at incredible speed while dropping toward Earth in a perfect curve, a continuous descent that never reaches the ground, a fall that has lasted longer than human history, longer than complex life, longer than almost anything we can truly grasp. And this is not just about the moon, it is about everything. The planets circling the sun, the satellites orbiting Earth, the structure of galaxies, the architecture of the universe itself. Gravity does not simply pull things down, it shapes paths, it sculpts motion, it turns straight lines into circles and collisions into orbits. It creates order from attraction. So the next time you look up at the moon glowing quietly in the night sky, remember this: it is falling, right now, at this very moment, falling toward Earth and missing again and again in a silent rhythm that keeps our world stable. That simple white circle above you is a masterpiece of physics in motion. If this changed the way you see the sky, make sure you subscribe to the channel for more deep dives into the hidden rules that shape our universe. Like this video so more people can discover the science behind the everyday wonders we often ignore. And share it with someone who still thinks the moon just floats up there. Because once you understand that it's falling, you never see it the same way again.